Welcome to the Executor Service Challenge. In this challenge, I want you to modify and enhance the Shoe Warehouse fulfillment code you created from the previous challenge video. I've included my own code if you'd rather use that in the resources folder of this video. You should use Executor Service classes, any of the three that I've covered, so use a single thread executor, a fixed thread pool, or a cached thread pool, or a combination of these. You use these instead of managing individual threads as you did in that previous challenge. This means you'll add an executor service in the main method to send orders to the warehouse. And you'll also want to add an executor service to the Shoe Warehouse class, which will fulfill orders. You should create and fulfill 15 shoe orders. Okay, so go away and give that a go. Pause the video here and see if you can figure that out. When you're done, or if you get stuck, come back and we'll walk through one solution together. Okay, so welcome back. How'd you do with that challenge? Were you able to change your code to use executor services instead of individual threads? Let's walk through my solution together here next. I've created a new project called Executor Challenge, and I've pulled in the two source files from my own solution to the previous synchronization challenge. In this case, I have the Shoe Warehouse class. I've also got a main class and an order record in the main.java source file. Let's quickly review what this code does. In the main methods code, we've set up a new instance of the Shoe Warehouse class. We've got to produce a thread that takes a runnable argument. This runnable generates 10 orders and calls the receive order method on the warehouse instance for each iteration. It then creates 2 consumer threads, each of which processes 5 items, calling fulfill order on the warehouse. To change this, first I'll remove the consumer thread code altogether from this method. It makes more sense to have the warehouse manage its own fulfillment threads. Next, I'll create a private method on my main class that'll generate an order for me. This will make the code in the main method a bit cleaner and easier to read. Don't worry if you didn't do this. This method can be private and static and returns an order. I'll start with a return statement next. Next, I really just want to cut out the code from the main method that creates a new order, omitting the last parentheses. I'll paste it after the return statement in my new method, and I'll add a semicolon at the end. Back in the main method, I'm actually just going to get rid of all the producer thread code too and start fresh in this method. For my producer side of things, I'm going to use a cached thread pool. I'll name this variable ordering service and get an instance of this using one of the static factory methods on the executors class. I could have used any of the three here. There's not really a right or wrong way, it just depends on what your objective is and how you want to use your resources. Since this code just adds orders, it should be fast and allow as many orders as possible to be submitted as quickly as possible. I'll set up a variable next, which is a callable and will process an order. I'll call it ordering task and set that up as a multi-line lambda. I use my new method to generate an order and assign that to a local variable named new order. I'll set up a try block because I want to have each task sleep for a random time between half a second and 5 seconds, so my orders won't be received all at once. This is just here to make watching the processes a little simpler. I'll call warehouse.receiveOrder, passing it the new order variable. I'll catch the exception, then throw a different type of exception. Finally, I'll return new order. Notice what I don't have here, and that's a for loop in the task. That's because I can use the executor service to fire off multiple tasks. What I'll do next is set up an array of these tasks. I can do that using the endCopies method on collections. First, I'll create a list. This is a collection of callables. I'll call this variable tasks and create it by calling collection.endCopies. This creates a list of 15 ordering tasks. I'll now call invokeAll on my ordering service, passing it my task list. I'll get an error on that line of code because I need a try catch, so I'll use IntelliJ to help me do that. Right now, I don't really need to get any information back when I submit an order. You could imagine maybe we might want a confirmation or something after submitting, but this is fine for now. I'll call ordering service.shutdown next. Then I'll wait for all the threads to terminate, but not longer than 6 seconds. And of course, I'll need a try catch around the await termination method too. I could run this now, but it's only one side of the producer-consumer equation. For this challenge, you were asked to include an executor service on the warehouse class, so next I'll switch over to the shoe warehouse class. I'll create a private final field on my warehouse class. It'll be an executor service type and I'll call it fulfillment service. In the constructor, I'll assign this new field an instance I'll get back from the new fixed thread pool method on the executors class. I'll pass 3 to this method, meaning this service will only ever have a maximum of 3 threads in the pool. I'll set up a shutdown method on this class so that this class's fulfillment service can be shut down smoothly. This will just delegate to the shutdown method on the service. Okay, so that's the setup for the creation of the thread pool. To use it, I'll add code to the receiveOrder method in this class. Before I do that, I want to include the thread name in the system.out.println method because it'll be interesting to see which thread is processing which task. In this case, I'll call submit on the service on this class, passing in a method reference to the fulfillOrder method. Okay, so now I have both sides of my consumer and producer code, both using executor services. In the main method, I've got an ordering service, a cached thread pool that's going to kick off 15 tasks using the invokeAll method. On the warehouse side, I've got a fixed thread pool with 3 threads available to handle the work. Before I run this, I'll add code to the main method. This will shut down the warehouse, which shuts down that thread pool service. If I don't do this, my application code won't shut down. Okay, so now, if I run this, I should get 30 statements printed, 15 from the threads that are doing the ordering, and 15 statements from the threads fulfilling those orders. The producer's pool is producing the incoming statements. This might be pool 1 or pool 2, but either way, look at the thread names for that pool. You can see that these start at thread 1 and go up to thread 15. The consumer's pool of threads are the ones that print fulfilled. These threads only ever have 3 different names, 1 through 3. This is because these threads are reused for tasks. In this example, my runnable code tried to include a delay between half a second and 5 seconds. I'm going to rewrite this a little bit. Instead of including the delay in the run method or as part of the executing task, instead I'll include the delay when submitting the task to the executor service, which is more realistic. I'll comment out the code that creates a list of 15 tasks as well as the invokeAll method. Instead, I'll set up a loop to submit tasks. I'll start with a try block. I'll use the sleep here so that the code waits a bit before submitting a bunch of tasks. I'll use a loop to submit each task separately. I'll use a one-liner lambda here rather than use the runnable variable I created earlier, since I don't want anything in this process to include an additional sleep. I'll run this. This output will look a lot like the previous output with 15 individually named threads in the producer's pool. All I'm really doing here is waiting up to 2 seconds, then firing off 15 tasks all at once, so the cached pool again increases to the same size as the tasks. But look what happens if I move that sleep statement to be inside the for loop. Running this code now. You can see there's a delay between each order being received. More importantly though, check out the incoming pool's unique thread names. I'm no longer seeing 15 unique threads in this case. I might just see just 1 or 2. Remember that a cached thread pool will also reuse threads like a fixed thread pool does. In this case, tasks are completing before other tasks get queued up and before the thread expires within 60 seconds, so the thread can be reused. The thread manager on this service determines the best time to create a new thread. because we're not submitting a lot of tasks all at the same time, it's reusing a single thread or two to handle the work. Okay, so that was the challenge. Remember, there's no right way or wrong way to set this up, and you might have tried a different executor or a different approach. Choosing any of the executor services we've covered so far could have worked as long as you submitted 15 orders and fulfilled all 15. The choice of submitting tasks here instead of executing them wasn't really because I wanted the data back. It's more common to use submit because the submit method works for either a callable or a runnable statement. Okay, so I hope you got a lot out of that and found it an interesting challenge. In the next video, I want to cover scheduling tasks. You saw in this video, I tried to delay submitting each task by some random bit of time. But we can also use a schedule executor to do this in a more controlled fashion, so I'll see you in that next video.